Alright, thanks for joining. This is Unit 3, Hands-On Hugging Face Reinforcement Learning course. So the link I'll put in the description. You can open this notebook in Colab. Here it is, Deep Q Learning with Atari Games using RL Baselines 3 Zoo. So this notebook, you're trained at Deep Q Learning Agent, playing Space Invaders using RL Baselines 3 Zoo, a training framework based on stable Baselines 3 that provides scripts for training, evaluating agents, tuning hyperparameters, plotting results, recording videos. We're using the RL Baselines 3 Zoo integration, a vanilla version of Deep Q Learning with no extensions such as double DQN, dual-link DQN, and prioritized experience replay. If you click on that link, this is RL Baselines 3 Zoo. Not familiar with this organization, but created from DLRRM, which is the German Aerospace Center, Institute of Robotics and Mechatronics. Oh, cool. So we got a German institute that funds this for us. Thank you, Germany. And it's a training framework for reinforcement learning using Baselines 3. Okay, so it uses Baselines 3 and it provides scripts for training, evaluating agents, collection of tuned hyperparameters for common environments, RL algorithms and agents trained in those settings. Okay, great. So this is going to help us train some models. So here's an example of what you'll achieve. So this is a video. Sure, I'll run this. And this video source is huggingface.co, Thomas Simoni, Space Invaders. Okay, great. So you're training a bot to figure out the Space Invaders environment. So, just looking at it, you can see that, there's, from what we read before, there's 3 actions. There's left, right, and shoot. And then the observations are all of these aliens, and the aliens can shoot back at you. So the objectives of this notebook, at the end of the notebook, you will be able to understand deeper how RL Baseline 3 Zoo works, and then you'll be able to push your trained agent and code to the hub. Perfect. Let's dive in. This is a prereqs. You should have read Unit 3. Let's train a deep Q Learning agent playing Atari Space Invaders and upload it to the hub. There's some instructions to validate. Okay, so for advice, it's better to run this Colab in a copy on your Google Drive so that if it times out, you still have the saved notebook in your drive and do not need to fill everything from scratch. So I will copy it. I will save a copy to my drive. Perfect. So let's go back to where I was. Okay. We're also going to train it for 90 minutes with 1 million time steps. By timing NVIDIA SMI, will tell you, by typing this, tell you what GPU you're using. And if you want to train more, such as 10 million time steps, it'll take about 9 hours, potentially resulting in Colab timing out. In that case, I recommend running this on your local computer or somewhere else. Just click File and Download. Okay, so we don't want the timeout. To accelerate, we'll use a GPU, so make sure you go to Runtime. You go to Change Runtime, and okay, so I have the GPU all good to go. And you have to save it. Okay, so create a virtual desktop. During the notebook, we will need to generate a replay video. To do so, with Colab, we need a virtual screen to be able to render the environment and thus record the frames. So let's just install all of these. Clone RL Baselines 3 Zoo repo. So you can now directly install from Python this, but since we want the full installation with extra environments and dependencies, we're going to clone the entire repository and not just the PyPy package. Okay, so we're going to install from source. So this will download the repo. Here you're CDing into the repo, and then you're getting setup tools, and then you're going to do pip install R requirements, and then you're also going to install Gym with Atari, and cool. So everything is still installing. It's going to take a while. But once it's done, we can move on to train our deep Q learning agent to play Space Invaders. So to train an agent with RL baselines 3 zoo, we just need to do two things. We define our hyperparameters in this YAML file, content RL baseline zoo hyperparams DQN. And if you click on here, let's see what happens. Oh, if you click on here, let's see what happens. Okay, so if you click on here, this is what it has for different environments. It looks like Acrobot, Lunar Lander, Cardpool, Atari. Okay, so this is where we're going to define our hyperparameters for Atari. You can see frame stack is 4. The policy is a CNN policy. And I wonder what these double exclamation points are, double bangs. Yeah, I wonder what that is. Okay, to move on, we see that. So we use the Atari wrapper that pre-processes the input, frame reduction, grayscale, stack 4 frames. Okay, so here's the stack 4 frames. I don't see frame reduction. I guess frame reduction is stack. Okay, anyways, we used CNN policy since we use convolutional layers to process the frames. Okay, we train it for 10 million time steps. Okay, maybe the double bang is a type setting, so it's double bang on float. Maybe it's setting that type as a float. Experience replay size is 100,000. Okay, so it looks like that's buffer size right here, aka the amount of experience steps you saved to train your agent, to train again your agent with, aka the amount of experience steps you saved to train again your agent with. Okay, so that's the experience buffer, so we're going to save some amount of time steps and then we're going to reuse that. My advice is to reduce the training time steps to 1 million, which will take about 90 minutes on a P100. Running this command will tell you what GPU you're using. Let's see what that is. Okay, so we're using a so this is NVIDIA SMI, the driver version, the CUDA version. The GPU name is this. The GPU is this, Tesla T4. Not sure what that is, to be honest. And currently using no memory because we're not doing anything. Okay. So I recommend running this on your local computer. I don't really want to run anything for 9 hours, so let's see what happens. In terms of hyperparameter optimization, my advice is to focus on these 3 hyperparameters: learning rate, buffer size, batch size. As a good practice, you need to check the documentation to understand what each hyperparameter does. So I think we know from learning rate is like, you know, how big of a step do we take when we want to adjust the weights in our neural network. Buffer size is that experience, that replay memory. Batch size is, you know, how many examples are we going to use to learn with and update our parameters all at once, right? So you click on parameters, you can search things like batch size or mini batch for each gradient update. What's the other ones? Buffer size, the size of the replay buffer, and learning rate. Yeah. So stuff we've seen before. Okay, so we run train.py and save the models on the logs folder. I don't know what this means. Oh, is this a problem? Okay, so this is a quiz, I guess. So this part is empty for us to solve. And so right here we're running, so this bang is going to say we're running in the command line. In the command line we're running Python train dash dash algo. The environment is Space Invaders, no frames, skip v4, and then I believe this f could be like a file name or something. And if you look in your contents, right, because we did copy it, so this is RL baseline zoo, then you should be able to find a train function, right? Train is here, train.py. Train.py is importing train from RL zoo3 train, so there is a train directory here, possibly. So RL zoo3 train, so here's a file. This is where it's getting train from, and train is going to be this, right? So train is going to be this function, and it's going to parse these arguments, right? And arguments here, like algo, will be the RL algorithm. So this is going to be some type string, and we're going to find the RL algorithm based on our choices. And the choices is in this algo's keys. And algo's keys comes from somewhere else, it seems like. But we could look at that in the documentation. And then the other argument is this dash f. If you just search this with dash f, you can see that this is the log folder, right? So it defaults to logs. So it's actually a default. We don't need to pass that in, actually. Oh, here's a solution. But yeah, so the DQN is going to be it's going to be the algorithm. Let's see. So here's train. So here's training an agent, and here's the algo name, right? Where is the algo's basic usage, custom file? Here the algo's PPO. Where's the list of algos? A little strange. Feels like it would be easier to find. PPO is one. Oh, here it is. Okay, so here's the RL algorithms, right? Act of the critic, DDPG, I don't know what that is, DQN, PPO, SAC, and because this is a DQN notebook, it's going to be a DQN, right? And here there's a dash F here, logs. It looks like if we don't put it in, it's the default, so we might not even need it, but let's just do it anyway for clarity. So the end registry is not iterable. Strange. Let's make sure we've downloaded everything. So we've run these cells. This one we've run this one. Downloaded stuff here, no errors. Downloaded Pyglet, no errors. Virtual display, no errors. Git clone. We git cloned it. We cd'd into this thing. We pip installed requirements, the gem. Okay, so defining our hyperparameters for DQNs, and that is a match, CNN, float, 100,000, batch size, learning starts, update interval, training frequency, gradient steps, exploration fraction, exploration percentage. If true, you need to deactivate handle timeout termination and the replay buffer kwargs. Okay, that's false by default, but I guess we can just make this true to match the example that we have here. Okay, we can double check what our GPU is, and then we can train. Alright, I'm going to Google this and figure out what's wrong. Okay, there's nothing on Google that points to this issue. So we can try to look at the code. It might not be that useful because maybe this is part of the gym deprecation because they wanted to deprecate gym for gymnasium. So maybe we can look at the code and see if we can do anything about this. It says the env registry object is not iterable. The code is, in here we have the code. So RL-zoo3 gym patches is actually right here. And if you search for env registry, it says right here, the patch registry. This registry is now a dictionary and no longer an env registry object. So here it says on line 82, they want to do patch registry dot update this thing, and that's based on gym patches, which is this, and that's based on RL-zoo train import train. So so we had this train function that we looked at before, and the parser takes all these and then it's going to eventually run some training command, right? So if you look at it, there's an experience manager, set up experiment. Let's just close that. Rx track import w. Okay, so you try to import weights and biases. If you don't have it, then you're going to run it and do something else. Here it's weights and biases.init, and it looks like the part that has the registry is here. So gyms.env registry.keys, and here's an update. So it's possible that the registration of these environments are now out of date. So if it's going to be anywhere, this question will probably be in the issues of the RL Baselines 3 Zoo. And the possible issue is going to be updating gym to gymnasium. Okay, I remember that from the Discord and the announcements. Okay, so I guess nobody has run into this issue, or it's an issue in the way that we've downloaded this library. I'm going to pause this again and do more research, because I believe it's probably pretty boring for a video to watch me do some research. But essentially what we're trying to do is to figure out on this line what we can do differently, right? So this line, which is 82, what we can do differently with this gym.env.registration.registry, right? And they said this is patch gym registry for PyBullet, patch gym time limit, patch gymnasium time limit. I mean, we don't even need time limit. We're just trying to do it on I wonder what would happen if we just commented these out, because we actually don't need these, because we just need Space Invaders. So I don't want some environment to mess up my Space Invaders training. Okay, so currently working, nope. And registry has no object.keys. Okay, so this is when you want to do this gym26 register. The gym26 register is this line right here, 163. So let's add gym 0.26 environments. So it's saying that this gym 0.26 environments has no object keys. I wonder why. So I'm just going to maybe import gym here. So if you look at this code, it's gym, 2.6, right? This is gym 2.6 right here. And I believe gym 2.6 is maybe the last version of gym that we're using. And I wonder what it looks like. So I believe what we're looking at is gym 2.6. .env. Okay, so it's this module right here. Registry. Okay, so it's this registry right here. .keys. And this is where it should break, right? It should break on not having access to keys. So this env registry has no access keys. So what is gym env's registry keys, right? I think that could be a question that you have. Totally valid question. And so what is gym, right? So anytime you download any Python library, it's going to be registered on PyPy. So gym is going to be this gym environment, right? Universal API for reinforcement learning environments, and we're going to be able to look at the code. So typically, there's a home page. This is the home page, and there's going to be some code, right? Now I don't know if this is going to be helpful, so we'll just see that this is the gym here, right? This is the environment here. Let's look at the init to see what it's exporting. So in the init, it's registering these environments: cartpole, mountain car, pendulum, acrobat, lunar lander, bipedal walker, blackjack, frozen lake, cliff walking, taxi, reacher, pusher. The thing that we care about really is Atari, right? It doesn't look like there's an Atari here. So we can keep investigating, or maybe we can just comment out this altogether, right? But ems.registry.keys. So what is ems.registry? So this is an init function, or it's the init file. Registration is here, and what is it registering? Okay, well, we would have to look up really what this is. So it's either in this file or it's in the init file, right? Or something imports it, where okay, so if it's not importing it, then register is a function that creates an instance of this class. Alright, so last ditch effort is to comment out this gyms entirely, because we don't need the environments in here. So comment this out. I'm going to save it, and if this doesn't work, I'll end the video here and create a new video when this is solved, and make that part 2. So, part 1 is we downloaded all of our libraries. We introduced a library that's going to help us train, which is the stable baselines one, and we are using this library to hopefully train this model, and we now have an error. It's a different error, which is good. So let's try to read this error. And if this doesn't work, then maybe let's just move on with the course to the next one. Okay, so the issue here was train, and the issue was in setup experiment and model at this algo, self.algos. Setting up the model, you're doing some seeds. It's going into the package of Gymnasium. Okay, Gymnasium has, it's resetting the environment for Gymnasium, resetting those, resetting more stuff. So it's just calling a reset all the way down the stack, and then it's going to take a step. So it's taking a step. There's a game over here with truncation equals false, and type error, game over, incompatible function arguments. The following argument types are supported, and this type should be bool, where it looks like possibly game over was called without a boolean. So I'd say this is likely a library error, or the packages that we've installed are the wrong version to allow us to keep going. We can do what we just did. We can go into this library and we can pass in a bool, but that would make for a pretty boring video. So I'm going to end the video here, and when I figure out the answer, I'll make a part 2 of this video. It's really a shame. But I'll figure out the answer and I'll repost. Thanks.